In this video, I will talk about the concept of inductance, and the symbol we use for inductance is the uppercase L. We have seen in Faraday's law, if I have two loops and say I have a current that's flowing in wire in loop 1, then from this current I1, I can use Biot-Savart law. So here I can use Biot-Savart's law to find the magnetic field that the current here creates at the location of loop 2. Okay, so I can use Biot-Savart's law to find the magnetic field from 1 to 2. Now, once I have the magnetic field here, we have seen that we can use the definition of the magnetic flux to find the magnetic flux that goes through loop 2. And once I have the magnetic flux that goes through loop 2, I can use Faraday's law to calculate the induced EMF that I have on this loop, on loop 2. Now here's the thing. For the concept of inductance, there is no loop 2. Everything takes place around loop 1. There is only one wire and that's it. So for the concept of inductance, I need to think that the current that flows in loop 1 creates a magnetic field at the location of loop 1. Right? We know that every current creates a magnetic field around it. So if this current creates a magnetic field here, as I said before, I know, of course, that it will create a magnetic field here as well. So this current creates a magnetic field at the location of loop 1. And again, I can use Biot-Savart law to find that. I can use the definition of the magnetic flux to find the flux that goes through loop 1. This is the magnetic flux that its own current creates. And again, I can use Faraday's law to find the induced EMF that a change in the current 1 will induce in the same loop. Okay, it is a little bit weird if you want. It is unfamiliar. Of course, with Faraday's law, we always had two loops, but it is we know experimentally that a change in current in one loop will actually induce an EMF in the same loop. Okay, so exactly same thinking process. Okay, nothing changes. Here I use Biot-Savart's law. Here I use the definition of the flux. Here I need to use Faraday's law to find the induced EMF in loop 1. It's exactly the same thinking process. The only difference is that there is only one loop. Now, okay, if you see here, okay, there are plenty of steps. Okay, so this is a lot of work. And we saw the same thing here. When we used Faraday's law, again, we did a lot of work. And there is nothing wrong with that. It is a long thinking process. Yes, there are several steps. The problems are not easy. Very, very interesting conceptually, very, very interesting to learn about how nature works, but it does take us time. Now, the concept of inductance, L, we use it actually in some cases to decrease how much work we do in all of this process, and I will show you why. Inductance is defined as the current. Okay, let's use. So I times the inductance can give us the magnetic flux. And what does this allow us? So you can see here, to go from the current to the flux, I need to first use Biot-Savart's law to find the magnetic field, and then I have to use a definition of the magnetic flux to find the magnetic flux. Now, Biot-Savart's law is fairly complicated, especially when you have something that does not look like a straight wire, or something that is not really a perfect circular loop, or it's not a solenoid. Biot-Savart's law it can be difficult to calculate. In some cases, you may even need to use a computer program to do the calculations if your wire, your loop is so has a shape that is so complex. In any case, this work sometimes this work is difficult. And if we replace this difficult work with a simple multiplication, the current times a number will give us the magnetic flux. This saves us from a lot of work here. Now, of course, this assumes that I know what the concept of inductance is, okay? Assuming I know the number. But if you do know the number, then this concept can save you from a lot of work here, okay? It allows you to bypass all of this and go straight from here to here with a simple multiplication, okay? This is using the inductance. So this is the usefulness of the concept of inductance. Now, how we calculate it is, of course, fairly complicated since we are bypassing some complex steps here. But the thing is, once you have the number, then you're done. You can use it for your system, whatever that is, as many times as you need to, okay, once you know the number. And sometimes when you buy a device, when you buy a coil, when you buy a solenoid, it is possible, highly likely, I would say, that this concept, the inductance, has already been measured from the company that makes those instruments, and they will tell you in the properties of that instrument. They will tell you, we did a measurement and we found the inductance of this instrument, of this solenoid, to be this number. So that once you get that instrument and you know the number, you can just multiply the current with the inductance to find the magnetic flux and then move on with the rest of your work.